All right, guys, welcome back. We are going to talk about horizontal translations. We've been already working on vertical translations, which go up or down. That's these bad boys right here. And then now we talked about coordinate notation, which is the X and the Y moving up or down if it's vertical. And lastly, we need to talk about horizontal translation. So take your book out and go to page 319. All right, page 319, here we go. Horizontal translations. This is going to be part of your lesson for the weekend, get you ready for your Chapter 5 exam on exponential functions. Let's begin. Consider these three exponential functions shown. So we have h. We have h. Is it okay if I just call them by their first letter instead of saying h of x? Is that okay? All right, we've got h and v and w. These are our exponential equations. What you should do is you should type these three equations into your Desmos. Go ahead and do that right now while I pause this. So open up Desmos and do these three equations. All right, looking back at the book, and we're talking about here, if you want to read this part right here, okay, the vertical translations were up and down on the y, but the horizontal translation is called the argument of the function. That's the x. It is the function operator. We can read this sentence right here. The argument of a function is the variable. Okay, so the argument is the x. It's the thing that we're plugging in, and on which the function operates. So in this case, 3 is added to the x, and x is subtracted from x. Okay, it's a little math and easy for most people to understand, but we can visually see that. All right, let's look at the next part. You can write the given functions v of x and w in terms of the basic functions x. So the basic one is going to be called h, and then the ones that are going to be translated are v and w. Okay, so we're going to write v and x and h and substitute that. So the same thing as we did before. So our basic function is h. That's our basic one. That's our generic one. And v is going to say, well, it's going to be whatever h is plus 3, which would be 2 to the x plus 3. So x plus 3 replaces the variable x. All right, so let's do that right here. Let me just bring this up a little bit. Write the function. All right, so number 1 says write the function w of x in terms of the basic function. So using the same idea as up here, we want to say, well, w, the line created, we're going to name it w, is going to be whatever h was with the argument x minus 3, okay, because we're taking 3 away. And that would also equal 2 to the x minus 3 power. We're basically referencing the other function. All right, and if you were to graph this, go ahead and copy this from your Desmos or graphing calculator. And I'm going to use different colors. For my basic one, I will use red. And here is, I'm going to call that one, I think that one was called h of x. That was the basic one, okay, which is 2 to the x power. And then I'm going to use green, the one that shifted to the left 3 units. And I think that one was called v of x. Okay, just call it v if you like. And which was 2 to the x plus 3. And again, notice that it says plus 3, but it's actually going this way, negative 3, when it's actually graphed. And then the last one, I'll choose a blue. And this one is definitely w. so we're just going to call it the line W, W of x, was 2 to the x minus 3. And notice how it says minus 3, but it actually shifts plus 3 from the basic one. The basic one is the one right here in the middle. All right, compare the graphs of v and w to the graph on the basic function. What do you notice? Well, we talked about it. We noticed that the blue one shifted. The blue one shifted to the right 3 units, but the actual stuff that was done to the x was minus 3, and then the green one, the v, got shifted this way, negative, with the plus 3. It's kind of backwards, but that's how it does. Okay, so we're going to describe that right here. Describe that right there in your own words. Okay, describe that. Go ahead and do that right now. And turn the page. Guys, I did actually bring Desmos up on here, but it'd be good if you type it yourself. For some reason, it doesn't actually save on my, it doesn't show on when I'm recording. I can see it, but you can't. Anyway, so I'm typing right now y equals 2 to the power. So I'm pressing the XB tool. You can press the caret on your computer, and then to the x power. And mine draws this right now. Okay, I'm drawing it by hand, but I'm trying to go right over it. All right, so that's that one. And now we're going to type in another one. And also, for that one, you want to type all right, you want to type on the next one. Down here, you want to type y equals, let me use it in blue. Y equals 2. And then you can do the caret or the AB, and then it'll be x plus 3. All right, so it'd be 2 to the power of x plus 3. And it's a weird thing because if you notice, it is the same shape, but it's actually 3 units away from this other one. I'm just going to kind of guess on this because I don't have the actual. So that is actually my mistake. It's actually not 3 units. It's 3 units the opposite way. See, I couldn't draw it. Let me press undo. And what's going to be cool for you is to understand, for some reason, when it's on the x side, when there's a horizontal shift, it goes the opposite way. It goes this way when it's plus 3. So notice this. When it's plus 3 on when the independent variable is being added 3, okay, the graph goes negative 3. It goes the opposite way. When we were going the vertical shifts, it would have gone up and down depending on what we're adding, but on the horizontal shift, it goes the opposite way. Okay, I would like to give you extra credit points if you can figure out why. Why does it go the opposite way? I'll give you 30 extra credit points. All right, so that is that one. And then the other equation, I'm going to choose to use green. The other function was y equals x 2 to the power of x minus 3. And go ahead and set that up, and you guessed it, it actually goes the opposite way because the transformation, the horizontal translation is being done to the independent variable, which is the x, and this would be going this way 3 units. So again, when it's minus 3, the graph goes to the right 3 units. And when it's plus 3, it goes to the left 3 units, kind of backwards. All right, so that is the horizontal translation of 2 to the x power. So looking back at our book, all right, so we're turning the page, and now in this one, we have to fill in the values. And I showed you really cool tricks here. On this one, they gave us the y already filled in right here. The y's is a quarter, half, 1, 2, and 4. Now, some basic knowledge is that basic knowledge you want to have in your utility belt. Your knowledge is that anything to the 0 power is 1. Okay, anything to the 0 power is 1. So if we look at this, hey, check this out. The y is 1. So how are we going to get 1 in here? Well, x has to be 0. Remember we saying 2 to the 0 power is 1. So this is the x right here. This is the x, the exponent. Oh, it looks a little messy. All right, dude, so we have, we're saying that 2 to the 0 power is 1, and we're going to replace x with 0, so we got it right here. Another idea we wanted to know was that here is the multiplier times 2. So 2 to the 1 power, so replace x with 1, and you can say, all right, 2 to the 1, well, that's 2. Okay. So where is the x equal to 2? Let's see. So here is the y. This will be the y version right here. So find when y is 2, right here. So therefore, the x has to be 1. Okay. All right, let's do another one. Okay. 2 squared is 4. And then look. Whoops. Look. Here's the y is 4. And then this tells you what the x is. This is the x, so that x has to go here. Now, I think you should be able to see the pattern here. 0, 1, 2. Looks like they're increasing by 1. So let's skip to that, to the pattern. Okay? So you can fill those in once you find a pattern with 3. All right, next. We want to say that on the v of x, right here, well, we're going to say it's going to be x plus 3 from whatever the other one is. So we could do a few of these, okay? Let's try it out right here. All right, let me erase some stuff here. Okay, so the value is, let me erase this, and that one, and this one. Just make some room here. I erased some of my values, let me put them back. All right, so we want to say, all right, okay, so the equation is, so the function is 2 to the x plus 3, okay? And then that'll give you your y. Can we use the same system to figure out when y will be 1? Okay, when will y be 1? When will y be 1? Remember, back your hip pocket says 2 to the 0 equals 1. So how can we make this become 0? So 3 plus what number is 0? You're going to say, hey, well, that x has to be negative 3. So therefore, so this number has to be negative 3, because negative 3 plus 3 is 0. And here is the y is 1, so we want to plug in here negative 3. All right, next, we want to do, let's see, how can we get an answer to be, how can we get an answer to be 2? Okay, well, think about a little bit backwards. 2 to the 1 is 2, okay? You agree? 2 to the first is 2. So how can we make this number become 1? How can we make this to become 1? Well, that would be 3 minus 2. So that would be your x minus 2. And I think you see the pattern already. You can just start filling it in. So this would be -4, -5. Okay? Now, check this out. It said x plus 3, but look what's happening to these numbers. From the basic equation to here, we're actually going -3. See the pattern? -3, -3. This says +3, and that's why the graph shifts to the opposite side. Okay? The graphs got shifted. So if we use the same logic right here, okay? So this one says +3, but then it went -3. This one says -3. So I'm thinking we're going to add 3 to this number, okay? So I'm going to do it to the easiest number I could add. I can add 3 to 0 really fast, okay? Would you agree with that? Okay, I just use a little pattern recognition to figure this out. All right, let's prove it just in one of these parts. Let's pull out our 2 to the 0 is 1, okay? So, and this is going to be a minus now. Now we're using this equation. So how can we get this to become 0? Well, you're going to say 3x has to be 3. 3 minus 3 would be 0. So here's a 1, and guess what number is next to 3? Okay? So we're saying 2 to the 3 minus 3 equals 1. Because 2 to the 3 minus 3 is 0, and that does equal 1. But I use pattern recognition to figure out the pattern here. This is one way you can show that the graph shifts to the opposite way as what's going on to the x. Oh, then you go ahead and answer this question. Okay, go ahead and pause it right here. All right, right here you have a little definition. A horizontal shift is a graph of a graph is a shift of the entire graph left or right. A horizontal translation affects the x-coordinate of each point of the graph. So basically we're saying the y's don't change. The y's stay exactly the same. See how the y's stayed the same here? 1, 1, 1, and 2, 2, 2, 4, 4, 4. The y's stayed the same. Only the x's shifted. So now if we do a little bit of coordinate notation, all we would say is that the y stayed the same, but the x is shifted. So what would happen for number 6? Okay, we'll say, all right, no big deal, okay? First, examine this. It says +3, so that means that the x's will go down 3, and the y's will stay the same. And consequently, on the other one, the x is +3, and the y's stay the same. And that happens because it says -3, so these go the opposite way. Real important distinction to know about horizontal and vertical shifts. Now let's read what these guys have to say. Let's see. So if a constant is added or subtracted outside of a function like g of x plus 3 or -3, then only the y values change, resulting in a vertical shift. So basically, if the number is added outside of the function, it goes up and down. This gentleman says, and if a constant is added or subtracted inside the function, then the x values change, resulting in horizontal translation. So you want to actually understand this very clearly, okay? This young lady says that the shift goes up or down if the number you're adding is outside of the function. And this gentleman says if the number you're adding and subtracting is inside the function, which is inside the parentheses, then the resulting is this way or that, the opposite direction, okay? So write that down in your notes so you can understand clearly what this is talking about. All right, number 7, okay? Describe each graph in relation to its basic function, all right? So we're going to compare f, which is b with some number minus some other number, to the basic function b of x. All right, so the idea here is b of x is the basic function, h. This is the basic function, which probably makes this kind of shape. It looks like it's exponential. And we're saying that c is a number bigger than 0, okay? Saying that c is a number bigger than 0, which means it's a positive number, okay? So if we subtract a number from here, it's going to cause a horizontal shift, and it says minus 6, so that means it's going to be shifting this way by c amount. It's going to be shifting by c. By c. And it's shifting because this says minus c right here. So if it says minus, it goes to the right. All right, try to do b by yourself. The idea is focusing on this. This is a little tricky question. It says minus c, but this says a number is negative. See, c is below 0, which is negative. So the opposite of a negative is positive. So it's opposite of a negative number. So this is negative. And this will be the opposite of a negative, which would make it a positive. So the shifting, I think, is going to go this way, to the left. Okay, but go ahead and draw it out. All right, here's the graph of the function shown. Sketch the graph of t prime and t double prime. Okay? I think that's how I would read this. When you put a little apostrophe, it's called t prime, and there's 2 of them. I'm going to call it t double prime. There's 2 of them. Not 100% sure that's how you would read it, but that's what I remember from my calculus class. All right, this guy says t prime says get t of x. This was t. Okay, that's t. That's t mountain right there. And this one says, hey, whatever you're going to do, you're going to add 3 to the x's. So I'm thinking, remember the idea, it says plus 3, and it's inside of the function. So I'd better move it to the left 3. So I'm going to actually zoom in on this one. And I'm going to pick some points here. So let's see, I'm going to pick this point. I'm going to move it 3 units to the left. Okay. 1, 2, 3. And then I'm going to pick this point right here and go 3 to the left. 1, 2, 3. Okay, and then I'm going to pick this one right here and put 3. 1, 2, 3. And I'm picking all of the corners basically. And I'm going to go 1, 2, 3 there. And the last point was right there. So I can reconnect. What do you think of that? So I basically redrew it 3 units to the left, and I'm going to call that one t prime of x. Okay. I'm going to use blue for my next one, and this one says it's x plus 1. Excuse me, minus 1. It says minus 1, so my brain says, hey, I remember I have to do this the opposite way. I'm not exactly 100% sure why yet, but I remember that. Okay. So I'm going to move 1 unit to the right. So remember, we're moving from the basic function. So it'd be, I'm going to do this one 1 unit, that one 1 unit from here, and then this one 1 unit there, this one 1 unit there, and this one 1 unit here. Okay, now I can connect my dots. And then my blue one, I'm going to call it t double prime of x. So that's how you do a funky shape like that. You do a few points and then you can connect them. All right, check this out, guys. Now you have to write a function of each that moves the translation 10 units left. So I don't know about you, but left means negative, which means I better add. Okay? So I'm going to say for number 9, it's going to be 5x. 5x. So I think I'm going to have to put this in parentheses. I'm not sure. X plus 10. Because remember, we're going to go to the left, which is negative. So that means the whatever we're going to do inside the function is opposite, will be plus. Okay, next one we have is 3x squared. So we're going to have 3. And then we're going to have x plus 10 squared. And last one I have is 1/2 x plus 10 cubed. Okay. Note there's a pattern here. This could actually be 1 here if you want. And try these out in Desmos to see try them out in Desmos to make sure that this is the original one and this one that we typed in does actually move 10 units to the left. And then that one right there is pretty cool. All right, so make sure on your Desmos that they actually are shifted. Okay. All right, guys, this is actually your lesson for your homework. And then on the next tutorial, I'll actually be working on the homework with you. So I know it's a lot, but you're intelligent beings that can work hard. So go ahead and finish this one off, and then we'll start the homework on the next tutorial.